Hello everyone, welcome to my channel Middleware Technologies. Today we are going to look at Kubernetes clusters important feature, that is Sidecar Container. So here in this article we will try to see how we can capture the HTTP traffic within a cluster between the pod to pod using a Sidecar Container feature that is provided by the Kubernetes cluster. So I am currently working on a Kubernetes cluster that is version 1.28.5. So let me go into my shell. So you need to have your Kubernetes cluster up and running for this demo. So right now I have a 2-node cluster. Basically one is the master node and the other one is the worker node with the version 1.28.5. So before going into the details of how we can implement this sidecar container in our cluster, let us try to understand what is sidecar containers. Basically we know we run pods in a Kubernetes cluster and that pod contains containers. So usually we have only single container with a single pod, but there is a facility to add more containers into the pod to enhance the feature of the application. So basically the purpose of the init container or sidecar container is to extend the functionality of our application which is running in the pod. So sidecar container is basically a extended feature, we can say, or improved secondary feature of the containers. So these sidecar containers basically run along with the main container or the application container within the pod, and these sidecar containers help to provide additional features or extend the functionality of the feature by basically providing logging facility or monitoring facility or data synchronization facility. So let's say if you want to capture the files that are generated within your application and transfer it to the cloud, you can use the sidecar container for that feature. So it will not be impacting your main application container with its functionality, and it will be acting separately in an isolated fashion. So that is the purpose of sidecar container. And sidecar container is basically different from the init container in the sense that init containers are the ones that are started up initially and they are completed. They are basically completed before the main application container is started. So that but in the case of sidecar container, the sidecar containers can run along with the application container. So that is the main difference between the sidecar container and the init container. Now let us go into our procedure, like how we can implement this feature, that is the sidecar container feature, in order to capture the HTTP traffic within the pod, basically the incoming and the outgoing traffic. So as a first step, as I said, we need to have our Kubernetes cluster up and running. So I have my Kubernetes cluster up and running. So I have a master node and I have a worker node, K8 node, which is on the version 1.28.5. Now let us go into our next step, that is enabling the sidecar container feature gate for the components. So right now, I am working on 1.28.5 version, and in this version the sidecar container feature is not enabled by default. So if you go into the documentation, for version 1.28 and go into the workloads, pods and sidecar containers, you can see starting with Kubernetes version 1.28, feature gate named sidecar containers allow you to specify a restart policy for containers listed in a pod's init container field. So it is possible to define our sidecar containers in the init container field. These containers can be restarted basically by providing this restart policy field. So these restartable sidecar containers are independent with other init containers and the main containers within the same pod. So that is the whole purpose of Sidecar container. Basically, we can restart those Sidecar containers and run it along the side of the init containers and the main application containers. Now, if you go into the FeatureGate link over here and search for Sidecar container, you see the Sidecar container feature is not enabled by default, so it is false by default. That FeatureGate is not enabled by default. So that is the first thing that we need to do. We need to enable that feature in the required components of the Kubernetes cluster. So let me go into each of the components. So let us first go into our Kubernetes cluster and let me do sudo so that I can access the Kubernetes components manifests, so which are available at the following location. So the components that we need to update are the API server, controller and scheduler, and along with these three components we need to update the kubelet configuration also. So first let me show you the API server configuration. So we need to add the following FeatureGate in the arguments for the cluster for the Kubernetes API server. This is a FeatureGate that I have added, and the Sidecar container feature is set to true. Once the API server is completed, like we can go to the next component, that is kube scheduler, and we need to set the same feature, Sidecar container enabled or true in this kube scheduler also. Now let us go into our third component, that is controller manager, and here also like you need to set the FeatureGate Sidecar container enabled to true in the kube controller manager arguments. So once these three are updated, you need to ensure that your Kubernetes cluster is accessible. Okay, it will take some time for it to reflect, for the pods to be restarted. So once that is done, you will be able to get the results, and you can just also ensure that all the pods are running. So once that is done, you can go with the next step, that is updating the kubelet configuration file. So here in my case I am running kubelet as a service. So if I search for kubelet, so I have the kubelet service running as a systemd service. So, and this is the config file that my kubelet service is using. So if I open this kubelet configuration file, you can just go to the kubelet configuration over here, and in the end you can just append this FeatureGate Sidecar container set to true. So these are the only two lines that you need to add in order to enable the Sidecar container FeatureGate. So once that is done, you can just save these results and restart your kubelet service. So once the kubelet service is restarted, you can just ensure that the kubelet service is up and running, and the same procedure needs to be carried out on your worker node also. So here let us search for the kubelet process and open the configuration file that it is utilizing, and you can just enable the FeatureGate, that is Sidecar container. So once all these four components are updated, we have fully enabled the FeatureGate so that we can utilize it in our pods. So now let me go into my master node, clear the screen. Now let us go into our next step. So we have seen updating the kubelet configuration. So that is done on the master node and on the worker node. The next step, step 3, is create a deployment with a sidecar container. So here in this step, I am basically going to use a deployment workload with 2 containers, and the one container is going to be our Nginx service that is going to be running, and in the other container, that is the init container, which will be acting as our sidecar container, we will be running a service which will be capturing the HTTP traffic from the pod interface. So let me try to explain it. So I am on the Kubernetes documentation again under the cluster architecture concepts. So here, like, we have these worker nodes which have these pods, and these pods basically will have their own IP address and their own interface. So the interface will be assigned an IP address internally, and what we are going to do is we have a pod with a one container which is acting as the Nginx service, and the other container is going to be capturing the interface traffic, that is the HTTP traffic packets, we can say in clear terms, and these packets are getting decoded and logged in our system out. So this HTTP traffic, whatever is incoming to the pod or outgoing from the pod, whether it is internal to the cluster or outside the cluster, that whole HTTP traffic is going to be captured using that sidecar container. So basically we are using this sidecar container as a logging facility or extended functionality for our Nginx deployment. And as I mentioned, like, the sidecar container is going to capture the HTTP traffic, basically the packets from the interface on which the pod is basically listening or assigned the IP address, you can say. So for this facility, the container needs to be executed in a privileged mode. So we will be looking at that in the definition file. So the sidecar container that we are going to use in this case is a GitHub project. So let me open this GitHub project. So this is a very interesting project that I have found on GitHub. Like, I got to know about this, and this is basically doing the job that we wanted to achieve, that is basically capturing the HTTP traffic within the pod. So here, like, we need to add the following image as a sidecar container and pass this config map. This config map is basically providing the configuration, like where we want to log our HTTP traffic, whether we want to log the HTTP traffic onto the system out, that is standard output, or whether we want to transfer these HTTP traffic logs into external service like Fluentd, Logstash, or Elasticsearch for further processing. So that is the whole purpose of this image that we are going to use in our demo. So now let me show you the config map and the deployment that we have prepared. Let me go into my Kubernetes cluster and open the config map first. So the config map is very basic. So this is the config map name, and this is the parameter that we are setting, send logs to standard out. So basically, like, whatever HTTP traffic is going to be captured, it is going to be sent to the standard out on the container logs. And now let us look at the deployment. So this is our very basic deployment that we are going to use for this demo, which is an Nginx deployment with 3 replicas. And here, like, we have the primary container, that is our Nginx service, but we have extended this function deployment definition file with this init container, which is the image that we that I have just spoke about. So this is the image Kubernetes pod-to-pod log that we are going to use, and we will set this restart policy as always, so that in case the container fails, it will be restarted and it will be able to capture and transfer the logs. And we are going to pass this config map as the environment, and this is the important thing, that is security context. We are setting this to privileged true. This is required because if we are not going to set this security context, the functionality which basically is provided by this image is not going to work, because this image is actually doing a packet capture on the interface of the pod, and it is trying to transfer process those HTTP packets into a JSON format and log into our standard output. So if this is not enabled, like we are not going to the container is not allowed to capture the HTTP traffic from a interface. So now we have seen about the definition on the sidecar container, and we have also seen the config map that is required for the sidecar container. Now let me go into my documentation again, and let us go into our next step. So we have looked at the deployment. Now let us go into the next step, that is step 4, deploying the application. Now we will be just applying those two definition files that we have prepared. So first let us apply the config map. So config map is already available. You can just look at the config map. So this is the config map which we have applied. And you can see we have the send logs to standard output set. Now let us apply the sidecar, the deployment with the sidecar container. So this is the definition that we are going to apply. Now if you look at the pods, it will launch 3 pods. These are the Nginx pods that are getting started. So let us give it some time so that they get initialized. So they are getting initialized. So one of the pod is running. So all the 3 pods are up and running. Now let me go to the documentation. So we have applied our definition files. The next thing that we need to do is we need to expose our application so that we can access it as a service. So what we are going to do is, so here we are going to expose our service, that is Nginx deployment, on as type node port on port 80. Okay. So let me run that expose command. So we have that service already available. So I have already created that service. So let me just show you that service. So this is the service that we have exposed. You can get into the details of this service. So this is of type node port and listening on node port 31568, and the container port is going to be port 80. So this is very basic, how we can expose our deployment so that we can access it externally from a node port. Let me clear my screen and go to the documentation. So now we have done the exposing of our application. The next thing, that is step 6, is generating the incoming and outgoing traffic. So now that we have the pods running with both the containers, there are two things that we are going to do. We are going to generate a traffic from node to port and from pod to internet. So from before doing that one, so let us just tail the logs for our pods. So let me do kubectl get pods and do kubectl logs. So our Nginx deployment is running, but I want to capture the logs for the sidecar container. So let me do capture the sidecar container name from here and clear the screen. Kubectl logs -c container name. So let me do the same command and do -c container name. So basically, like in this pod, we are trying to tail the check the logs for the following container only. So here you can see there is a service which has started, like it is ready to listen for the HTTP traffic on the interface ETH0. That is the internal interface of the pod. Okay, so now let us try to generate some traffic. So here, like what I will do is I will try to hit our Nginx deployment using the node port, which is exposed as a service, and try to access the Nginx default page, which is welcome to Nginx. So you got the response. So we have tried to hit the service externally. So let us try to hit it. And now let me clear my screen. And now let us try to validate the logs. So you can see the logs have been captured. You can see that the JSON format in which it is captured and the details that it has captured. Like the type is incoming, the source IP, the source port, the destination port, and from which host that we are trying to access this service. So all these details are getting captured, and this is getting captured on the standard output of that pod. But as I said, like we will be able to send this traffic, send this captures to an external service also, like Fluentd, Elasticsearch, or Logstash. So that is a facility that is provided by that image. So let me clear my screen, and now what we do is we will try to go into the container. So let me go into the container, get a shell for this, and now from this container, like we will try to access a external service. So let's say like I'm trying to curl google.com. So you can see we are able to get a response. Now let me get out of the shell and try to capture the see the logs for that container again, and you will see like the outgoing traffic capture has been done, and you can see the host which we are trying to access and the destination port, that is port 80. So this is how like we are able to capture the service, able to capture the HTTP traffic from an interface of the pod by running that pod or the container within that pod as a sidecar container. So that is the purpose of this sidecar container. So let me go into my documentation. So step 7 is basically, as I've already shown, that is capturing the logs. But the thing that I wanted to mention is the security context that we need to enable. So let's say I'll remove that deployment. So right now it is running. So let me delete that sidecar container deployment. And now let me go to the definition file and try to comment this one. So if you comment this one in the init container, and if you try to apply that sidecar container deployment, it is going to create the deployments and the containers, but the container is not going to start up. So the init container, basically the sidecar container, is not going to start up. So let me show you the logs for that one. So here, like, we need to check the logs for that specific container, that is K8's port-to-port log, and you will see that it is not able to open a socket in order to capture the interface traffic. So this is the purpose, like we need to enable that security context, but in a production environment you might not have a chance to enable that security context, because it is basically providing a privileged access to your container, and if something goes wrong with that container, like your whole security is going to be compromised. So that is one thing that we need to take care of before enabling this one. But this is a very good feature, we can say, that a sidecar container that can provide us. This is only one use case that I have shown you, but there are many use cases in which we can use the sidecar container along with the application pod that application container that we are running in the pod. So yeah, that is all I wanted to show you in this video. I hope you enjoyed watching this video. Thank you all. Thanks for watching this video, and you guys have a great day.